Autocad Electrical 2016 Black Book. Chapter 1, topics cover the major topics covering the chapter, the need of the drawing, electrical drawings, common symbol of electrical drawings, wiring types, and labeling. Need of drawings. In this book, we're going to go through the topics for the related with the electrical wiring posed for the creative of the good electrical wiring. So important, know the electrical drawing. What is the role of the Autocad electrical in that? When working with the electrical industry, we need to have a lot of the information handling, handy like wiring, machine position switches, loading every machine, and so on. It's almost impossible to remember all the detail of the industry because of these over 1,000 wire switches. There could be hundreds of machines. Making this possible, we need electrical drawings and written and printed documentation of these, and Figure 1 shows an electrical drawing. Shows a circuit diagram, some transistors over here, rectifier bridge right here, and 4 rectifiers, tooth position, and then some another transistor, transformer, ground, capacitors, inductors, and resistors. Electrical drawing. Electrical drawings are representation of electrical components with a connected wire fulfilled with the specific purpose of electrical drawing can cause industry. Electrical panel. Also, electrical drawings can be divided into the following categories: circuit diagram, wire schedule, block diagram, part list. Circuit diagram. Circuit diagram shows how the electrical components connected together. Symbols either represent the components, lens, represent the functional conductors or wires which connect them together. Circuit diagram derived with the block of a functional diagram, Figure 5.2, but it does not generally bear any relation with the physical shape and the size and layout of the parts, so you could wire up any assembly information given in usually intended to show the detail on how electrical circuits work. Shows a 3-phase motor with a tolerance, and then 3 knife switch open and push button with a temperature start and motor cutout switch, start and stop, and wire diagram. The drawing, it shows all of the wiring between the parts, such as the control, single function of the power supply, earth connection, termination, you can use leads, contacts, interconnection, V with the terminal points, block with the plug, sockets, lead throughs. It will have the detailed shift of the terminal identification numbers with enablers for the wire unit. Together, the parts of the diagram may be simple as shown in the block, no indication as to the electrical components inside of these usually or sub-assembly may be separately, i.e. pre-assembled circuits or modules. Figure 3 shows the wire diagram. Alright, Figure 3 shows a wiring diagram with some terminal boards and there with the pins. Wiring scheduling is defined with the wire reference number, the type of the set of the number of the conductors, length of the mount with the insulation strip to required with the soldering complex equipment that must also find with the table of the interconnection, which give the starting of the first reference point of each of the connection, as well as the other important information such as the wire color, identification marking, and so on. Refer to Figure 4. Alright, wiring scheduling shows the wire number from, to, and the type of the length and the strip length, and the motor control, and the number would be 206A. Block diagram and the functional diagram you either show with the describe of the main operating principles of the equipment usually drawn by the cigarette diagram and started. It will not give any real detail with the actual wiring connections, even the smaller components, only limited into the wiring control panels and equipment shown with the block diagram. Alright, show the panel shown in the block diagram with the main contactor, reversing contactors of the motor with the direct control external switches. Alright, your part list. Although not drawing itself, in fact, it may be the part of the drawing. The part list gives a vital information. It relates to the component type of the circuit drawing reference normally either the locate with the cross-reference the actual component, code numbers to ensure that you have the correct part of the commence for the wire of the job, and then show the reference of the bin number, the description, and the code for the part list. You now have the various type of electrical drawings, but the drawings contain various symbols. Either the following symbol section with the common symbols in the electrical drawing, symbols of the drawing. Symbolism of electrical drawings. Symbols of the electrical drawings can be divided in various categories. They are explained in the next. Conductors. There are 12 types of symbols with the conductors, Figure 7 and Figure 8. These symbols are explained next. General symbol of the conductor, group of conductors, temporary connection with the jumper, 2 conductors, single line representation, 4, 2 conductor middle lines, 3 of 5, single line representation of the conductor, 6 twisted connectors, twisted conductors, twisted pairs in the example, and it shows 1, your general symbol, 2, the temporary connection jumper, 3, 2 conductors single line, 4, 2 conductors multiple lines, 5 single line, end conductors, 6 twisted conductors, and then Figure 7, general symbol to denote the cable, and example 8 conductor 4 pair cable, and 9 cross conductor no connection. Figure 8 shows the 10 and 11 show the junction with the conductors connected to the 11 with the double junction of the conductors, and 12 alternate U with the double junction. Connectors and terminals. Figure 9, routing general symbol of the terminal and tag symbol, also U with the contact of movable links, open circle with the U with the representative of the easily separable contact solid circle, U with those that are bolted. Alright, so solid circle means that it's broken. Open circle represents a contact, and it just shows a general connector and terminals. 14 would be a link with two easy separable contacts. 15, a link with two bolted contacts. 16, hinge link normally open. 17, a plug. 18, a socket. 19, axle plug, coaxial plug. 20, coaxial socket. Inductor's transformer. 21, general symbol of color winding. 22, a ferromagnetic core. 23 is a transformer symbol. Resistors, to refer to figure 11, the general symbol. 24, old symbol, sometimes U fixed resistor fixing tapping. General symbol of variable of resistance, alternative old variable of resistor preset adjustment. 2 terminal variable of resistance rheostat. Resistor positive temperature coefficiency, resistor negative temperature coefficiency. So you first have a general resistor symbol and an old symbol, and then you have a 25 would be a fixed tapping to it. 27, adjust a variable resistor pentagraph, and 28, alternatively old. 29, variable resistor. 30, 2 terminal variable resistance, and then 31 and 32 are a resistor positive temperature and negative temperature thermostat. Alright, capacitors, general symbol of the capacitor, and then polarized capacitor, observed polarity, making connection, polarized container, electrolyte, variable capacitor preset, and then shows the capacitors are double dash, and then fuses, general symbol of the fuse, some supply symbol, angle, thick line, orientation, holder symbol. Shows figure 38 shows a general symbol for a fuse. 39, supply, thick line, supply side. 40, alternative symbol. Switch contacts, brake contact, and brake contact version 1 and 2. Older, main contact, brake contact, BSI, alternate making contact version 1 and 2. Changeover, brake contact, alternate showing maker before brake and brake before make. So it shows you these basic switches. Switch type, push button, switch monetary, push button, push on, push off, latching, lever switch, 2 position on and off, key operated switch, limit position switch. It shows the brake or make. The 51 is a push button, push off, and then make or break. 51, 52, and 53 key operated lever switches. Diodes, rectifier, single diode, single phase bridge rectifier, 3 bridge rectifier arrangement, transistor silicone controlled rectifier, air SCR, general symbol, resistor, common, Jude track, and so number 55, single diode. 56, a single phase bridge rectifier. 57, three phase bridge rectifier arrangement, and 58, transistor single controlled rectifier. 59, transistor common usage, and 60, try a two-way transistor. Earthing shows the ground symbols, along with above the symbol discussed. You might need to use some divine symbols for the representation drawing. After learning the various symbols, the next important thing to learn about wire and specification. Wire and specification, electrical unit, U for the wide variety of the wire and cable types. If you to be able to correctly identify U for the wires which have been specified with the wrong wire types will cover the operational problems called rendering, could render the unit unsafe. Such factors include insulation material, size of the conductor, what it's made of, whether the size, solid and stranded, flexibility, type of the wires, single solid stranded wires, not very flexible, U for the various connections, acceptably able to preferably U for the high current application of the power switching contactor, may be uninsulated. Standard wire, flexible, most interconnections between components are made with it. Braided wire, also called screen wires, ordinarily insulated conductor surrounded by conductive braiding. In this case, the metal outer is not used for the current carry current from the normally connected to the either to provide electrical shield to screen internal conductors from the outside electromagnetic interference. Wire specification. There are several ways to describe the wire type. The most read the method is specified with the number of strands, with the conductor diameter, with the strands, with the cross-section area of the conductor. Then the insulation type. Refer to figure 18. For example, the 1 means a single conductor wire. The conductor is 0.6 millimeter diameter, is insulated with a PVC. Conductor also constructional section. Conductor has a cross-sectional area nominal to 0.28 millimeters, and it shows an example. Your standard wire gauge. Solid wire can also be used in the standard wire gauge or SWG system. The SWG standard wire gauge number is equivalent to the specific diameter of the conductor for figure 90. For example, the 30 single wire gauge is a quarter of a millimeter diameter. 14 single wire gauge is 2 millimeter in diameter. So you're going up when you go up and lower the number. Lower the gauge number, the higher the millimeter. The larger the number, the smaller size of the conductor. There's also an American wire gauge, which uses the same principle, but both numbers and size do not correspond to a simple standard wire gauge. And it gives a table: 14, 2 millimeters; 16, 1.63 millimeter; 18, 1.22 millimeter; 20 standard gauge; 0.91 millimeter; 22 standard wire gauge, 3/4 of a millimeter; 24, 56 10 hundredths of a millimeter; 25, 5/10 of a millimeter; and 30 quarter of a millimeter. We are at the position we know that the various schematic symbols we know the wires, but now we learn about the labeling contactor. The labeling marker for the component for the defining the incoming outgoing source for the further figure 20 for the attaching number to the side of the wires. Later they can be identified with these circuits. Figure 20 shows the contact for the colors are alphabetically A1, A2, A1, A2, odd numbers including supply terminals, even numbers outgoing terminals, and main contacts marked with a single number. Odd numbers include supply terminal. Next, even number outgoing terminal. In this way, we find different type of the markings on the contacts that would include in our drawings. Chapter 2: Introduction to AutoCAD Electrical and Interface.